This slide shows an idealized sketch of three thermal emission spectra from three stars. Antares is a red giant with an emission temperature of 3400 Kelvin. Our Sun is a fairly normal star with an emission in the yellow-green part of the spectrum as its maximum and has a temperature at 5800 Kelvin. Spica is a white dwarf with an emission temperature of 23,000 Kelvin. On the x-axis in wavelengths, we can see the emission maxima of the stars, which are pointed to with arrows at the top. So, for example, Antares is something less than 10,000 angstroms. That would be around 1,000 nanometers. In the infrared, our eyes can't detect the maximum of Antares, and the red color really is from the tail of the emission spectrum that we can see with our eyes. The Sun, of course, we can see. It's not a good idea to look at it directly because it's quite bright, but we know from many measurements over the centuries that its maximum wavelength is around 520 nanometers or so. That's 5,200 angstroms. And Spica, as you can see from this diagram, has an emission maximum that's in the ultraviolet. Now, it appears white to us, white dwarf, is the name of that type of star, because the tail of the emission, that blue tail that you can see, spans really the entire visible range. And so all of the visible wavelengths are fairly equal because the tail is maybe weighted towards the blue end a little bit, but all of the wavelengths are pretty equal. And so it appears white to us, hence the name white dwarf. In actuality, the star is emitting in the ultraviolet. And if you were anywhere near that star, you obviously wouldn't want to be looking at it or even experiencing its radiation in any way, because 120 nanometer radiation is ionizing radiation. It's extremely harmful to life. So to sum up, we can see that there is a relationship between the maximum wavelength of emission and the temperature of these stars. And that was known empirically at the end of the 19th century. That relationship shown at the top of the slide is known as the Wien Displacement Law.